Because it's a very good question. It's because this is x squared and this is x. This is y squared and this is y. I cannot set them equal to each other.
Solve for x, then solve for y.
Very good. So let's solve for x. Excellent. It's only substitution in this situation when this is a nonlinear equation and this is a linear equation, only substitution. Very good. So can anyone solve this equation for y? I need to hear everyone speak, please.
Would you subtract a times x and...
I'm solving for x.
Oh, I thought you were solving for y. Okay. Yeah, you said solve for y.
I said
Okay.
we're solving for y.
Yes.
If I said that, then I have to keep my promise.
Okay. Subtract a times x, so that it would, and then over b.
That's it. Very good. So I'm going to replace y in the first equation. So this is x squared plus ax over b, with minus or not, it doesn't matter. When I square, it's not going to make any difference. Good. So then I have x squared and then plus a squared x squared over b squared equals r squared. Can anyone help with the next step, please?
Move the x squared to the other side.
No, I have both terms with x on one side, so I want them there.
Take the square root of r.
I cannot take the square root from a sum. Not allowed. That's why it's so important to communicate. It's okay to make mistakes, really. Don't be shy. Anyone else?
You multiply by b squared?
Great job. Very good. Assuming b is not 0, of course. So then we have x squared, b squared x squared, plus a squared x squared equals b squared r squared. Perfect. Eliminate fractions. Eliminate fractions. Very good. Perfect. Next. Remember, the target is we are solving for, anyone? What are we solving for?
X.
Very good. Awesome. Next step.
Divide both sides by b squared x squared.
I cannot.
We factor out x squared.
Brilliant. Very good. What is left in parentheses?
B squared plus a squared.
I'm perfect. Since I can write it in the correct order, I'm going to do that. Good. Excellent. Now,
Divide by a squared plus b squared on both sides.
good. So
And then
finally, now I can take the square root. And now I will have to write plus or minus br over the square root of a squared plus b squared. Good. Okay, so that's wonderful, but I don't have the point yet. I only have x. So it appears I'm going to call them, you don't have to. I'm going to call them P and Q. I have the x coordinate, br over the square root a squared plus b squared, and minus br over the square root of a squared plus b squared. But now I have to determine the y. How do I determine the y? We are getting there. Anyone?
You should plug x back into one of the equations.
Right? I don't want to go back there. Oh, no, no, no. I want to go back here. So then the y value will be x multiplied by negative a over b. Okay? So let me write it here. I'm going to copy it. So y equals negative ax divided by b. So therefore, y will be negative a over b with a plus or minus br the square root of a squared plus b squared. So the first, with the positive one, I have negative AR over the square root of a squared plus b squared. And then the one with the negative, I will have positive AR over the square root of a squared plus b squared. So in step one, I found 2 points of intersection. Well, infinitely many points of intersection, of course. But each two, every pair, meaning every circle with a line, they will meet in 2 points. The next in line, the next circle with the next line will meet in 2 points. But infinitely many, because of the parameters here. Okay, so
I have a question.
yes?
Can you pull back that the sheet of paper that you had? So for the y value for p, wouldn't they be swapped, because wouldn't the negative have to go with q?
So negative with the positive one.
I see it.
I chose it positive in P. So if I chose it positive in P, if it's positive and I multiply by negative A over B, then this one has to be negative. If this one is negative, then the other one will be positive. Is that okay?
Yes, I forgot to recognize.
That's okay, no worries. Okay, so now in step 2, find derivatives for both. Okay, I'm going to copy them so I don't have to go back to that page, for now anyway. And this is ax plus by equals 0. So it means that from here I want dy over dx, and I'm going to call it a. No, not a. 1 for the first equation, and I'm going to call this one dy over dx for equation 2. Good. So how do we get dy over dx for equation 1? So let's say Josh. I haven't heard you yet. Josh?
We did for both points?
Say it again.
Can we get the derivative for both?
I want to find dy over dx for the first equation. What do I need to do?
Not exactly sure.
Okay. Carson?
Would you start by taking the derivative of x squared and y squared?
Sure, I'm ready, of course.
So it would be 2x plus 2y. Times, would it be dy over dx?
Well done. Equals?
Would it be 2r?
What do you think, anyone?
Is that the
My
derivative?
dx.
What would this be?
Oh, wow.
Ian? Sarah?
Would it be 2?
It's a constant. How many variables can I have in here?
2.
Right.
So it was r
0.
squared just 1.
Exactly, of course. I can't have more than 2 variables. We're only talking about x and y. Everything else is a constant. If you want a parameter. Good. So then I'll move to x, divide both sides by 2. So then I get dy over dx equals negative x over y. And this is the dy over dx number 1. Because it comes from the first equation. Okay, who would like to, Ian, would you like to help with the second one? Ian, are you with us? 1, 2. Derek, how do I determine dy over dx for the second one?
A.
Yes,
No, the letter A.
I got it. Yeah.
B times dy over dx
Excellent. Equals?
equals 0.
Of course. So now from here I have the dy over dx equals negative a over b, and this is coming from the second equation. Great job. Perfect. Okay, in step number 3, I check the points of intersection. And I check the points of intersection and the slopes of the tangent lines there. Okay. Good. So we have 2 points of intersection. I had them some time ago. So at P, I'm going to copy BR over the square root of A squared plus B squared minus AR over the square root of A squared plus B squared. The slope 1 at P. So the slope 1 at P is negative the x of P over the y of P. So negative x of P BR over the square root of A squared plus B squared over negative AR over the square root of A squared plus B squared. Can anyone give us this answer? Kush, would you like to give it a try? Kush, are you with us?
Yes. I'm not sure.
Okay.
Give me one second.
Good. So we simplify these two. We simplify the R, and we have B over A. We have to look at the slope at P, but for the second one. And the slope at P for the second one is negative A over B. Negative A over B. So I got this for the first one, and I got this, the slope for the second one, at P. What does that mean?
Their slopes are perpendicular.
Exactly. We know that M1 times M2 has to equal negative 1 for perpendicular lines. You probably remember it as M1 equals the opposite of the multiplicative inverse. I don't like this. It's the same with that. Cross multiply, the product is negative 1. It's even easier to say product negative 1. Here I have to say one slope equals the negative multiplicative inverse of the other. It's the same thing. So we show that the slope at P of one line, one tangent line is B over A. The slope at P of the second tangent is negative A over B. If you multiply these two, you will get negative 1. In the same way, we will do the Q. And I'll let you finish it because it's exactly the same. Any questions? Any questions?
What chapter is this from?
It's still chapter 3. It's chapter 3. Okay, we're moving on to section 3.6, derivatives of log functions. And we're also going to talk about logarithmic differentiation and logarithmic differentiation. That's my habit. Always run out of room.